Welcome to this presentation about synthetic control. Today I'm going to introduce you basically a different way to run tests in situations or environment where A/B testing cannot be used. So just an introduction, my name is Alessandro, I'm a data scientist here in Spring, and I'm working in the advertising intelligence team. Basically in this team, we want to utilize our data to increase advertising revenue and also to empower data-driven decisions at Media Impact and Spring as well. So our current project is dynamic floor pricing. I will spend a couple of slides talking about this project, and then we can move on in the synthetic control framework. So let's start from the overall idea of the project. Here you can see a build webpage with 3 different ads. And the green spaces, rectangulars here that you can see where the ad runs usually, they're called placements. So we'll refer to these names during the presentation. So how we sell placements in Axel Springer. Let's see, yeah. Okay, so basically every time a user loads a web page like the one you saw before, for each of the 3 placements, so for each placement, there's an auction that runs. So in these auctions, different buyers will bid to win this specific placement. So they will basically bid the price they are willing to pay to show their ads. And there also exists a minimum floor, which is usually called floor price, which is the floor that and it's basically the minimum price we agree to accept, talking about bids. So that means that in this example, for example, since no bids are above this floor price, we have no winner and the placement will remain empty. There's also clearly the other case in which we have some bids that are above this floor, and so the highest one will win, and then we have a winner and he's able to show his ad on the placement. So the goal of our project is basically to adjust or change dynamically these floor prices that, again, we are basically the ones who change those. So the idea is changing them to and then setting to a new ideal floor prices to maximize the revenue. So clearly, to tackle this problem, our goal, our idea is change to a new floor prices and observe to a new floor price and observe the outcome of this change to see if the new one is better or worse with respect to the previous one. So for this kind of problems, usually A/B testing is the solution that is applied. So just a quick recap or definition to what A/B testing is. The idea behind A/B testing is to define 2 groups. The control group, where we will run all the floor prices, and the test group, where we will run the suggested ones, so the new ones, the ones we think are better. And how this is done, so all the auctions, so for each auction that runs, it will be assigned to control or test in a completely random way. So in the long run, we will then, in theory, be able to compare, for example, revenues from control and test. So we'll have a huge number of auctions for control, a huge number of auctions for test, and we're able to compare the various KPIs that we can have. Unfortunately, in this current framework, we have various problems that lead us to an impossibility to apply A/B testing completely. So first of all, for example, we have technical reasons. So Xander, which is one of the platform we are, so where auctions runs, do not allow this setup at all. So it's not possible to generate this randomized idea of separating an auction. Besides that, there's also a logical problem behind. So that is a bit more hidden, let's say. So since the split of an auction of auctions is independent one to another, a bidder could, in theory, bid for an auction T, so this one on the left, which is, for example, in the test group, and then it could try to bid for the next auction, the T+1, which is maybe in the control group. And if he bids adapting to the outcome of the previous auction, he will basically try to adapt that something that changes over time, because the floors will change between control and test, and ending up basically mixing the effect of our test both in the control and the test group. So the takeaway of this is we cannot apply A/B testing, so we had to think about something else. And this is where synthetic control comes from. So the idea behind synthetic control is, instead of having test and control groups separately, we now want to apply the new floor prices, the suggested one, to all of the auctions that we have. But of course, we want to compare the revenues that are coming from these new floor prices with something that should kind of tell us what would have happened without the change, right? So the idea is to create this, it's called synthetical twin, which is basically created mimicking the treated placement, so the one in which we change the floor, pretending that no treatment was applied. So to do so, the behavior, so we extrapolate some behavior both from past data of this very same placement we're trying to study, and some informations about all of the other placements, so also placements where we didn't change anything. And ideally comparing, so for example, here on the right, this is an example from the first paper on synthetic control. The dashed line is the synthetic model, and comparing the real one with the synthetic one, we should be able to understand if the change we've made is like a good change or not. And so thinking again at the previous problem that we had, now this problem is not existing anymore because the control group doesn't really exist. It's something that we have on our machine, so it's just a model, and all of the real world auctions will all be matched in the test group. So let's go just a bit deeper in how the statistical model works. I won't dive too much into details, also I think it can be a bit boring, let's say, but I want to focus on two factors that I think are really important to understand how synthetic control works. So suppose to select the placement I, which is the one we want to run tests on, and capital Y will be the outcome, for example, the revenue of this of all of the auctions that we will have on this placement. So the first factor I want to focus on is the one related to X. So X is a vector of observed features, which basically means that we're going to study the bidder behavior on this very same placement before the start of the experiment. So trying to understand how bidders used to bid on this very same position, so at this very same placement during like past so days before the start of the experiment. And this is clearly done only on the placement we are studying, because different placements will have different ways of bidding, let's say. And then there's also a second factor, which is a vector of unobserved factors. It's called unobserved, and those factors basically summarize the bidder's current behavior on all of the placements that you have. So we're not talking about past data anymore, but we're also talking about current data. So this was a bit hard for me at the beginning, like not clear. So, but you can think of maybe even in this moment of Corona, if we imagine to start an experiment, let's say 1 month ago, and then probably all data from this placement are not enough to imagine what would have happened without the change, right? Because Corona can change the way in which bidders bids. And that's why we are using the current data of all of the other placements to kind of understand the overall behavior of bidders. So at the end of the story, our synthetic control is basically a linear model, which has these 3 classes of objects, as I said before. We have the yellow stuff, so the observed features, the red one, the unobserved, and some interaction effect between all of the features that we have. So before coming to some results, I think it's interesting to have a quick hint on the unobserved factors, so the red ones that I showed before. So as I mentioned, we want to have an idea on the overall trend in demand, not only for the placement we're working on, but for all of them. So our idea to create these kind of factors is to use the mean bids per placement. So for each placement, we're able to see how high or low on average are the bids, and to create these 2 factors as the principal components of this mean bids per placement. So instead of having hundreds or thousands of factors, 1 for each placement, we will just summarize this seasonality or trend in demand into these 2 factors. So for example, this one on the left, we can see clearly that we have some kind of daily seasonality from the mean bids point of view. But yeah, those are principal components. So if you have worked with principal components, you know that it's a bit hard to give an interpretation, like a real interpretation of those. But the overall idea is to kind of summarize this trend among placements. So let's see some results. So of course we want to test, even in a graphical way, how our synthetic control is working. So in our opinion, the best way to do that is creating what is called placebo experiment, which means that we select a placement and we pretend to change the floor price, even if in the end we don't change anything. So if synthetic control works good, it should be able to mimic the placement in the best possible way, right? Because no actual change has been made. And so we have this experiment that started on 1st of March. And as you can see, results are pretty good because the control group, which is the synthetic one, kind of is able to match the test one, which is what we observe in the real world. So what actually is happening on our website. So after having validated this synthetic control from a graphic point of view, let's say, let's finally see how we use it currently in our project. So this is a real example on the 7th of April. So where you see the vertical black line, we started an experiment. So we select the placement and we change the floor to a floor that we thought it was better for this placement. And so we took some training data, which is basically the faded part of the plot where the experiment didn't start yet. And as you can see from the 7th on, the results are better. So our results is the blue, actually. I don't know exactly which color is that, but like we can see that the blue part for both of these KPIs is higher than the red one. So the red one is basically our synthetic control. So what would have happened to the placement without the change of the floor. And so this is like a nice way to check on a daily basis how the new floor price is adapting, let's say. So yeah, in this case, the new one is better than the old one. So this closes my presentation. I think we have a couple of minutes for a question, if you have so. And also here on the right, I have left you some interesting stuff, in my opinion. So there's a paper from Google, which like uses synthetic control. And there's also, in my opinion, like super clear talk by Uber at the Pi Data conference in 2019 in Amsterdam. They applied synthetic control for some examples, real case examples. And it's incredibly clear how they explain it.